Hey guys, this is Miss Gable here. I'm going to show you guys how to do this week's assignment. This is RM13. And so what you guys are going to do here is you're going to actually practice using APEMAN. So real quick, let's review what that is. A equals P equals E. Okay, so we use this to calculate the subatomic particles of a stable atom. And a stable atom, let me review what that means real quick. It means that the number of protons and the number of electrons is equal because protons are positively charged and electrons are negatively charged. If they're not equal, then we have a charged atom. And then it gets a little bit more complicated from there. And that's some stuff that you guys are going to start with in high school chemistry. But for us, for 8th grade science purposes, add the number of protons and the number of electrons. For us, for 8th grade science purposes, we are working with stable atoms. So protons and electrons will always be equal. So your atomic number is equal to the number of protons, and it's also equal to the number of electrons. And then we have MAN. This is going to be your mass number, and you're going to subtract your atomic number to get the number of neutrons. So you have a list of elements here, and you're going to go have to find their chemical symbol. You're going to write down their atomic number and their mass number, and you're going to use that information to calculate the subatomic particles. Okay, so I'm going to do boron as a example for you guys. So boron's our example, and we're going to find that on the periodic table. So I zoomed in so you guys could see it. Boron's right here, and its chemical symbol is a B, a capital B. And its atomic number is 5. And its mass number is 10.806 AMU, but I'm going to round that up to 11. The number of protons. So how do we find that? So we're going to look back up here. Number of protons, P. The number of protons is equal to the atomic number and the number of electrons. So my atomic number for boron is 5. That means I have 5 protons. And that means I have 5 electrons. Now the number of neutrons. This takes a little bit of a calculation. So we have to take our mass number and we're going to minus our atomic number. So my mass number is 11 and my atomic number is 5. So 11 minus 5 is 6. So I have 6 neutrons. Okay. So I'm going to do another example. I'm going to do mercury. So one of the things that's going to be challenging about this activity is you guys having to find them on the periodic table. So I'm doing mercury. And the first thing we do with mercury is we need to find its chemical symbol. Okay, so I'm going to look for the name. I happen to see it right there, mercury. Its chemical symbol is capital H and a lowercase g. Okay. And its atomic number is 80. And its mass number is 201. Now on the periodic table, it says 200.59. But for our mass number, we round up. So I'm going to round up from 200.59 to 201. Now I need to calculate the number of protons. So if we refer back to the top, protons equals atomic number and electrons. So my atomic number for mercury is 80 so that means that I have 80 protons and 80 electrons. Now for the number of neutrons, I have to take my mass number of 201 and I'm going to subtract my atomic number of 80. So 201 minus 80, and you guys are welcome to use a digital calculator or some scratch paper. So when you subtract them, you're going to get 121 neutrons. Okay, so you guys are going to complete all of these elements. You're going to go find them on the periodic table, and then you're going to type in their atomic number, their mass number. Be sure to round. You're going to round from the decimal up to the nearest whole number, and then you're going to calculate the number of protons, neutrons, and electrons. If you guys need assistance with this, please check out my APEMAN instructional video, and I go over 4 more different examples for you guys.